friends, welcome back. Miss Tessler here. Visualize a number line that's partitioned into fractional parts. You can close your eyes if that helps you imagine. What do you notice on this number line? What do you know about using number lines to represent fractions? How do you think we could use a number line to compare fractions? Open your eyes if they're closed and come on back. That's exactly what we'll be doing today, using a number line to help us compare fractions. Here's what you'll need for class today. Pause the video to gather your materials. Ready? Set? Let's go. Look at your number line template. What do you notice? What do you wonder? Maybe you noticed that there are several number lines printed for you and that they're all labeled the same. They have 0, 1/2, and 1 labeled. How do you think we'll use these numbers to help us with today's task? These 3 numbers are very important for our reasoning about fractions. These are our benchmarks. A benchmark is a point that can be used to measure something. We will use these 3 numbers to measure and compare other fractions. We can think about how close they are to 0, 1/2, or 1, just like you did at the start of the lesson. Remember to pause the video whenever you need more time to think, write, or draw. Let's begin. How many sixths equal 1 whole? Say the unit. 6 sixths. How many sixths equal 1/2? 3 sixths. Is 2 sixths greater or less than 3 sixths? It is less. So then, is 2 sixths greater or less than 1/2? It is less. Using the first number line next to 1 on your template, partition the number line to show sixths. Label only 1/2 and 2 sixths. We can see on the number line that 2 sixths takes up less space than 1/2, 3 sixths. And we wrote a number sentence comparing 2 sixths and 1/2. Take a moment to write this number sentence. Great! We just used our knowledge of equivalent fractions to compare 2 sixths and 1/2. Let's try comparing another fraction to 1/2. Think for a moment, then tell me, is 2/3 greater than 1/2 or less than 1/2? 3 is an odd number, so there is no number of thirds equivalent to 1/2. Think about 1 whole in unit form as thirds. 3 thirds. Now, think about the unit as cookies. If you had 3 cookies to split in half, each person would get more than 1 cookie, but less than 2 cookies, somewhere between 1 and 2 cookies. So 1/2, when thinking about thirds, is somewhere between 1 and 2 thirds. Partition your next number line into thirds. You can cover up 1/2 with your finger if it helps you to see how to make 3 equal parts. Notice how 1/3 is less than 1/2 and 2/3 is greater than 1/2. Look for a moment at the first number line you drew. What fraction did you show is equal to 1/2 on that number line? 3 sixths. Can we decompose thirds into sixths? We can. What happens then? Decompose your thirds into sixths. We can see now that 2/3 is equivalent to 4/6. And we know that 4/6 is greater than 1/2 because 1/2 is equal to 3/6. When we find equivalent fractions that have the same denominator, 4/6 and 3/6, we can simply compare the number of units, the numerator. Cool, that's another way to reason about 2/3 and 1/2. So since 2/3 is equal to 4/6 and 4/6 is greater than half, we can say 2/3 is greater than 1/2. How are you doing so far? Let's do another one together. Think for a moment, then tell me, is 2/5 greater than 1/2 or less than 1/2? I'm thinking about how 5 is an odd number too, like 3, so it doesn't divide evenly in half. Halfway between 0/5 and 5/5 should be somewhere between 2/5 and 3/5. So I would say that 2/5 is less than 1/2. Let's check that reasoning using a number line. Model 2/5 on your next number line. Then compare 2/5 and 1/2. Here's 2/5 on my number line. Where is yours? Are ours in about the same place? It looks like 2/5 is less than 1/2. I could also check by decomposing each of the fifths into 2 parts. I could do it on the number line or with multiplication. When I decompose each fifth into 2 parts, I make tenths. I know 5/10 is the same as 1/2 and found by decomposing that 4/10 is the same as 2/5. So that's another way that I can reason 2/5 is less than 1/2. Write a comparison sentence using a symbol to show 2/5 is less than 1/2. That would look like this. Next, we'll plot a few different fractions on the same number line. Get ready. Think, then tell me. What do you know about 5/12 in relation to 0, half, and 1? Maybe you said 5/12 is greater than 0 and less than 1. Or maybe that 5/12 is about halfway between 0 and 1. You might have remembered that 6/12 is equal to 1/2 and noticed that 5/12 is less than 6/12. So it's a little less than 1/2. Plot and label only 5/12 on your last number line. Where do you think it should go? What do you think? Is yours in about the same place as mine? Is 5/12 closer to 0 or closer to 1/2? It looks closer to half, but how close is it? How many 12s? Remember, 1/2 is equal to 6/12. So 5/12 is only 1/12 away. That's closer than it is to 0. It's 5/12 away from 0. What do you know about 7/8 in relation to 0, half, and 1? It's greater than 0. It's less than 1. It's greater than half, I think, because how many eighths are equal to half? 4/8. So 7/8 is between half and 1. Now think, is 7/8 closer to half or closer to 1? Think about how many units away from each benchmark. 7/8 is 3/8 greater than half and only 1/8 less than 1. Plot and label 7/8 on the same number line as you labeled 5/12. Notice where each number is. Write a number sentence comparing 7/8 and 5/12 using a symbol. Here's where I put 7/8. Is yours in about the same place as mine? And 7/8 is almost 1, so it's greater than 5/12, which is almost half. Let's do one more. Plot 2/6 on the same number line. How does it relate to the other points on the number line? Consider the size of each unit. I know 2/6 is less than 7/8 and definitely less than half. It's going to be really close to 5/12. I think I'll plot it right here. I'm not quite sure which of these two numbers is closer to half. They're both 1 unit away. I can reason about the size of those units. Which is larger, 1/6 or 1/12? The more units are needed to make one whole, the smaller each unit is. 6ths are larger units than 12ths, so 2/6 is farther away from half than 5/12 is. Now, write a sentence to compare 5/12 and 2/6. 5/12 is greater than 2/6. To compare fractions that have different denominators, different sized units, we can compare the distance of a point from either 0, half, or 1 based on the size of the fractional units. We can use these important locations on the number line as benchmarks to help us compare fractions. Keep this in mind as you work on the problem set. The must-do problems are on the screen. Set a timer or watch the clock for 10 minutes